3.6, part 2, composition of functions. So suppose that f of x is equal to the square root of x and g of x is equal to x squared plus 1. So we may define a new function h as h of x is equal to f of g of x. We read this as f of g of x. Every time we're using those parentheses, we're writing of. This is not multiplication. This is really using g of x as the input to the f of x function. So first what happens here is that x gets put into the g function and we get an answer. And then we're going to use that answer as our input for the f function, and that will give us our final solution. In general, when we're given any two functions, f and g or whatever we want to call them, we start with a number x in the domain of g. So whatever we're putting into first, it has to be in that domain. And we're going to find its image, basically its output. If this number, whatever g of x is equal to, is also in the domain of f, then we can calculate f of g of x, because to put it into the function f of x, we need to make sure we're in the domain to begin with. The result is a new function, f of g of x, and that's obtained by substituting g into f. And it's going to make a little bit more sense as we go through some examples, but we call this composition of or just composite functions. And what we're doing is putting really g into f. We're putting a function into a function. So it's denoted, it almost looks like fog. I don't know why it turned up dashed. It's just something strange that Google did when I downloaded it as a PDF. It should just be like f circle g. It looks like fog, but it's not the word fog. The circle is a little smaller. When we read that as f composed with g, it means the exact same thing as f of g of x. And honestly, I think this notation makes a little more sense, but you'll see both of them. So it's good to know that they mean the same thing. Also, sometimes you'll see it written like this, f circle g, and then, or f composed with g, or the composition of f and g of x, and it means the same thing, f of g of x. So the domain of f of g of x is the set of all x in the domain of g, such that g of x is in the domain of f. So you need to make sure kind of that x is following, well, it's not making any issues along the way. So it's not just the final answer. It's not just the beginning answer. You kind of have to play with it to see what's going on, and we'll see that in a little bit. So in other words, f of g of x is going to be defined whenever both g and f of g are going to be defined. Okay. So let's try this. So again, I don't know why that circle ended up so big. It's just something that Google Docs did for me. It should look a little bit more like f circle g, but it means the same thing. So we want to let the function, or find the function f composed with g, or f of g of x, and its domain. So we're going to find f composed with g, which really means f of g of x. So what we're going to do is replace this g of x with what it is equal to, x minus 3. So really we have f of x minus 3. And now this kind of looks like the problems we did before break. We're going to replace the x in the f of x function with whatever's in parentheses. So instead of x squared, it's going to be whatever is in those parentheses squared. So now we can FOIL that. It doesn't matter if you want to leave it like this or FOIL, whatever. That's x squared minus 6x plus 9. Okay. So we want to also find its domain. And in order to find the domain, we want to think about a few things here. First of all, are there any restrictions on each of these functions to begin with? So is there any restriction on what x can be in the g of x function? No, right? It can be all real numbers, no worries there. Is there any restriction on what we can square? No, again, that can be all real numbers. And then we want to just take a final look at our last answer. There's definitely no restrictions there, so it's all real numbers. So here our domain is just going to be all real numbers, or if you want to write interval notation, it'd be from negative infinity to infinity. So however you want to display that. Using the same functions, we want to find f composed with g of 5. So instead of x, we want to put 5 into the function. So we could do a few things. We could skip right to the answer, or maybe if we didn't have it, I could show you what we can do here. So we want f of g of 5. So we have a few things we could do. Like I said, we could just go right to that answer we already worked out, Or I can find g of 5 first. So g of 5 we're going to get by replacing x with 5. So that would be 5 minus 3, or that would give us f of 2. And then I'd just be plugging 2 into that function. So something squared, that's 2 squared. Oops. That was weird. I don't know why it wasn't recognizing it. So we're going to get 4. We could have gotten the same thing if we had plugged into that original function. We said f of g of x was equal to x squared minus 6x plus 9. So we could plug in 5. That would be 5 squared minus 6 times 5 plus 9. So that's 25 minus 30 plus 9. Negative 5 plus 9 is still going to give us 4. It's the exact same thing. So either way you want to do it is perfectly acceptable. All right, the next we want to find g of f, which is a little bit different. So instead of inputting g, we're inputting f. So that means g of f of x. All right, so we're going to first put f of x into the g function. So we have g, we're going to put f of x in there. F of x is x squared. And then we're going to replace the x value in g with that x squared. So that's going to be something minus 3, or that's going to be x squared minus 3. Okay, so we do get different answers depending on the order that you do these in. And then the domain, again, we want to make sure, was there a domain issue with either of those functions to begin with? The answer is no. Is there any domain issues here? Do I have any fractions, any radicals, anything like that? So no, all real numbers, we're good to go. And then we can do the same thing. We can either work them out separate, or we can just plug into what we've already worked out here. So we have g of f of 7, and we can really either, plug back into the beginning, or we can just use what we just found. So that would be 7 squared minus 3. So 49 minus 3 is going to give us 46. All right, so same concept. We're just going to find all sorts of different orders here using the functions. So we have the square root of x, and then we have the square root of 2 minus x, both which are going to have specific domain restrictions, right? When we take the square root, we need to make sure we're using positive numbers, or just non-negative really. So in this first one, we want to make sure that x is going to be greater than or equal to 0. In the second one here, we want to make sure that x is, that 2 minus x is greater than or equal to 0. So when we work that out, might be easier to just add x to both sides. So that really means that x has to be less than or equal to 2 for this to work. Okay. So depending on the order will really kind of determine what the domain is going to be. So let's work these out first and then find the domain. So we want f of g of x. F of g of x. So first we're going to replace g of x with the function. So that's f of the square root of 2 minus x. Okay. Then we are going to replace x in the f of x function with what is there. So that normally would be the square root of x. So this is the square root of 2 minus x. Now that looks super messy. Just remember, square root is actually the half power. So I could rethink this as being 2 minus x to the half, and then that all to the half. And that might make this a little bit nicer. We would multiply exponents, so that's actually 2 minus x to the 1/4. Or if you want to put it back to a radical, it's the 4th root of 2 minus x, which might make it look a little bit cleaner. All right, so now that we have it simplified, we need to talk about the domain. So first of all, we want to make sure that we are accounting for the fact that whatever issues there are with g of x, that x doesn't have a problem. Okay, so we want to make sure that we're using x's that are less than or equal to 2. Not a problem there. But we also want to make sure that whatever we have here is going to also be not an issue when we go to take that square root. So we want to make sure whatever we plug into this x doesn't create an issue here. Now we know that it can't create an issue here because when we take the square root, we're going to get a non-negative answer. So we just have to double check that this will work, but it should be that our domain is going to be that x has to be, less than or equal to 2. And let's just double check. If we put 2 in to here, right? If we put 2 in here, we'll get 0. Square root of 0 is 0. If we put things smaller than that, like maybe we put 0, that'll give us 2. If we put a negative, it'll be turning into addition, so totally fine. All right, if we then took the square root of whatever we got here, right, square root of that positive answer, we're still going to be perfectly fine. And even if I put something in here, that x is less than or equal to 2 is going to be just fine for us. So here is our simplified version, and here is our domain. Now, I know it seems kind of silly, like, oh, x has to be greater than or equal to 0, but it doesn't. Whatever g of x turns out to be has to be greater than or equal to 0. So really this is saying that the square root of 2 minus x has to be greater than or equal to 0. Not this x, but whatever we're inputting to the f function. All right, let's see. Hopefully a few more examples will make this make a little more sense. So g circle f, or g composed with f, or g of f of x. All right, again, so order does matter. We're going to put the f of x function inside the parentheses, so that's the square root of x. And then what we're going to do is put that square root of x in place of the x in the problem. So it's the square root of 2 minus the square root of x. Okay, so certainly a different answer here. I can't just start multiplying things out. This is pretty much as good as it's going to get. So we have to consider a few things here. First of all, when we do f of x, which is the first thing, we have to account for the fact that that x has to be greater than or equal to 0. So when we're talking about domain, we definitely need to worry about x being greater than or equal to 0. We're just going to kind of do some scratch work over here. And that's because of this x right here. Okay, now if that x is greater than or equal to 0, we also have a little bit of an issue. I want to make sure that this doesn't cause any issues with the big radical. So whatever I get here has to be 2 or smaller, right? Because if I put, say, 3 here, whatever the square root of x is, say that came out to 3, it's not going to work for me. 2 minus 3 would then give us a problem. So we also want to make sure that that square root of x has to be less than or equal to 2. 2 is the last acceptable number there, which would really mean that x has to be between, let's see, negative 4 and 4. Okay. All right, so now we have a few things to consider. Not only does x have to be greater than or equal to 0, but it has to be between these two numbers. So now I need to consider what is the kind of most restrictive when we include them all together. So x has to be greater than or equal to 0, and it has to be less than or equal to 4. So that means my domain is going to be between 0 and 4. So if you want to write it like that, or if you want to write it from 0 to 4, that's fine as well. Either way, doesn't matter. It means the same thing. Oh, how did I do that? All right, f of f. So we have f of x. Okay, so again, we're going to put f of x in there. So that's f of the square root of x. But then we're going to use this in, well, the same function. So the square root of whatever's in parentheses. All right, so we got square root. So really we can think of this as x to the 1/2 to the 1/2. So that's really x to the 1/4, or that's the 4th root of x. Okay. So a few things going on here. I want to make sure when I'm talking about domain here, I need to make sure that x is greater than or equal to 0. And then whatever the square root of x is, I want to make sure is greater than or equal to 0 for the next radical, which works out to be the exact same thing, that x has to be greater than or equal to 0. I just double check down here. As long as x is not negative, we're in good shape. So our domain is going to be that x is greater than or equal to 0, or if you want to write it in interval notation, we're going from 0 to infinity. Either one of those is perfectly fine.